So I thought I'd do another quick video for this past paper question. This is from the 2018 paper, and it says Roman pottery contains traces of metals. The metals present can be identified using atomic emission spectroscopy. Analysis of a sample from a Roman pot produced a series of spectral lines. The data in the table shows the results for 3 of the spectral lines produced. There's your results. Part 1 says name the metal that produces the orange-yellow spectral line at 589 nanometers. For this, you need to go to page 15 of your data booklet. You're looking for the wavelength that matches 589, and there it is down the bottom. Sodium with a wavelength of 589, producing an orange-yellow flame. So your answer is sodium. The second part of that question then says a 4th line was observed in the spectrum obtained from the Roman pot sample was caused by a transition with an energy value of 282 kilojoules per mole. Calculate the wavelength in nanometers of this spectral line. So we know from last week that to work out energy, that's how we relate it to wavelength. So if we want to rearrange that, it is just nice and simple, just like that. So plugging in all the values, L, Avogadro, 6.02 times 10 to 23, multiplied by Planck's constant, 6.6, there's not a dot in there, 63 times 10 to negative 34, multiplied by the speed of light, which is 3 times 10 to the 8. Here we're going to divide that by our energy value, which is 282, and because the units are given in kilojoules, and because Planck's constant is in joules seconds, we need to convert kilojoules to joules by multiplying by 1,000. When we plug that in our calculator, we get 4.25 times 10 to negative 7 meters, because the unit for speed of light is meters per second. The question asks us to give the answer in nanometers, so we have to divide that by 10 to the negative 9, giving us 425 nanometers as our final answer. 3 significant figures is absolutely fine for your answer here.